Hello. All right. I want to make sure that you completely understand the greenhouse effect and how it works, this relationship between electromagnetic radiation and our atmosphere of gases. So grab your colored pencils, and we're going to start off with the Earth. The Earth is mostly water, so I'm making my Earth blue. Okay? So we just have kind of part of the Earth there that we're going to focus on. And we now know that the Earth has a layer of gases surrounding it. And so that is our atmosphere. So we're going to put our gases around our Earth here. And you don't have to go too crazy with the number of dots here, but you know, you get the general idea that our atmosphere is composed of these molecules of all different types of gases, but in this particular circumstance, we are interested in carbon dioxide, right? And methane is CH4, and maybe some ozone, O3. These are all greenhouse gases because they have more than 3 atoms in their molecules. Okay? So now we have to add in our electromagnetic radiation. And the radiation that we're talking about is coming from the sun. So I'm going to add in our nice happy sun here. Okay? And we know that the sun is giving off a certain type of radiation called ultraviolet radiation. That's what we try to protect our skin from so we don't get sunburned. And we've already discussed the fact that the electromagnetic spectrum has some types of radiation that is short waves or high energy, and some that have longer wavelengths that are lower energy. Well, UV is a short wavelength, high energy, okay? So you want to make sure that you draw these like short little wavelengths here, okay? And you can label it UV rays. And you might even want to label it high energy. And I would make a little arrowhead here that shows that, see, most of it is getting through this layer of gases here because it has high energy. It is able to break through this layer of gases. Some doesn't. Some might bounce off here. And some might bounce off the Earth. But for the most part, our UV rays are making their way down to Earth and heating up our sand, our land, and our water, just like in our land versus water lab. Now, everything is radiating some form of radiation. So I'm giving off heat. You can't tell, but I am right now. The Earth also is giving off radiation. But the radiation that Earth is giving off is a lower energy than what the sun's energy is. And Earth is giving off this long wavelength called infrared. This infrared does not have enough energy to get out of these molecules. And so it ends up bouncing off the molecules and getting stuck here, trapped between the atmosphere and Earth. This is the greenhouse effect. If you've ever been to a greenhouse that grows flowers and vegetables and stuff, they have glass ceiling, glass walls, because it lets the ultraviolet rays in and it traps the heat inside there, keeping it nice and warm. Even when it gets cool in the spring and the fall here, they can grow vegetables in this nice warm greenhouse. So we want to label these long waves as infrared, and we want to say that they are low energy. So they get trapped, okay? So we want to make sure that you label this as the greenhouse effect.